Hello and welcome back to the third part of the higher order derivatives lesson. So far we practiced how to find the second derivative in functions where we had to apply the power rule. And then we looked at some functions where we had to apply both the product and quotient rule as well as the power rule always. And now we are going to practice how to find the second derivative in implicit equations. So our first example for implicit equations will be number 3a. So let's get started. We are ddxing each side, which means that we are ddxing or finding the derivative of every term. So 5y minus ddx of xy to the power of 2 equals ddx of 1. So as you see here, we have implicit differentiation. So derivative of 5y in terms of y is 5. And then times dy dx. And then minus, notice that here we have product rule. So open up brackets, you will have two terms. Derivative of x is 1 times the other factor y squared. And then plus, the derivative of y squared is 2y dy dx. And then times the other factor, which is x, close brackets. That equals the derivative of 1, which is 0. So now we have to solve for dy dx. So let's simplify a bit more. 5 dy dx minus y squared minus 2y times x 2xy dy dx equals nothing. So dy dx is our variable. So we have the terms with dy dx on the left and the other term on the other side. So these are the two terms with dy dx in it. So we can take 5 dy dx here minus 2xy dy dx equals y to the power of 2. Take dy dx out. And then in brackets we have 5 minus 2xy equals y squared. So we'll say that dy dx equals y squared divided by 5 minus 2xy. So here goes the derivative, the first one. We'll continue differentiating the first derivative so we get the second derivative. So I'll rewrite dy dx here equals y squared over 5 minus 2xy. Okay. So to find the second derivative, again, we have to use the quotient rule. See that you have a product in here as well. So we'll write d squared y dx squared equals, the derivative of the numerator is 2y dy dx. This will multiply the denominator, which is 5 minus 2xy. Now, because we have quotient rule, means that we have a minus in here. And we're going to take a look now at the derivative of the denominator. Careful, because we have a product in here. Let me make this green. I like green. All right. So the derivative would be, for 5 is 0, right? So basically the derivative of the denominator will be based on the derivative of this term. So we'll say that derivative of negative 2x is negative 2. So I'll write it, I'll look at it as a product of these two, right? So that's negative 2 times y, which is the other factor. And then plus, so the derivative of y is dy dx times the other factor, which is times negative 2x. in brackets. And all this will be over the denominator squared. Denominator squared is 5 minus 2xy to the power of 2. So let's simplify a bit more here. We have 2y dy dx multiplying 5, 2y dy dx multiplying negative 2xy, and then we can take this one out and we can take this one out. So I will leave the first term in factored form to start with, which means 2y dy dx 5 minus 2xy. And then I will open up the square brackets here. So we have plus 2y, and then plus 2x dy dx. All this will be over 5 minus 2xy to the power of 2. All right? So what we're going to do this time, because we have simplified as much as possible, we can take number 2 out as well. All right? And that will leave us with equals. So a factor of 2 outside the brackets. And then we have y times dy dx. And that multiplies 5 minus 2xy plus 2y, plus y plus x dy dx in brackets. Okay. And, sorry, I think this would be enough here. And this will be over 5 minus 2xy to the power of 2. Now, this is as much as we can simplify the second derivative. So this would be d squared y dx squared. So what we want to do is replace dy dx here. And what do you replace it with? Y squared, 5 minus 2xy. The reason why you want to do this is because you want to express d squared y dx squared, or the second derivative, only in terms of x and y. So we don't want to introduce a new thing in there. So here we go. We have 2. We have y, which multiplies y squared over 5 minus 2xy times 5 minus 2xy. Isn't this nice? And then plus y plus x times y over 5 minus 2xy. And all this will be over 5 minus 2xy to the power of 2 equals. So notice how here we simplify these two terms. And we'll have 2. And I will join this y with this y squared. That will give y to the power of 3. And then plus y to the power of 1 plus xy to the power of over 5 minus 2xy. So these two will multiply each other, right? Now all this will be over 5 minus 2xy to the power of 2. So you see how we have a plus in here and a plus in here? And all of them are under the denominator, 5 minus 2xy to the power of to the power of 2. So one thing that I'm going to do here in this case is leave 2 out, and we'll have y to the power of 3 over 5 minus 2xy power of 2 plus y 5 minus 2xy to the power of 2 plus xy over 5 minus 2xy. So this term in here is right here. Now multiplied by the reciprocal of 1 over 5 minus 2xy to the power of 2. And I will close the brackets. And I would rewrite this in a more simplified form as 2. Then we have y cubed plus y 5 minus 2xy to the power of 2 plus xy 5 minus 2xy to the power of 3. And this is a simplified form. Obviously, we can continue simplifying by bringing them together under the same denominator, and that will be done by multiplying here by 5 minus 2xy to the power of 3. So you still have number 2 in here. We'll multiply numerator and denominator by 5 plus 2x minus 2xy, so that we can have the same denominator. So long fraction line, 5 minus 2xy to the power of 3. We can expand this. That would be 5y to the 3. And then minus 2x y to the 4 here. And then plus 5y. And then minus 2xy squared. And then plus the xy, so this xy here. As you can see, we don't have any like terms in here. We do have a y in common, right here, which we may take out. And that will make the second derivative in the most simplified and factored form 2y, 5y to the power of 2 minus 2xy3 plus 5 minus 2xy plus x over 5 minus 2xy to the power of 3. And this would be d square y dx squared. And we'll celebrate by boxing this up. All right. So this is probably one of the more difficult and more complicated or algebra-heavy derivatives or high-order derivatives that you can encounter or deal with in grade 12 calculus.